Okay, here we go, our first recording of the year. Let's see how this works. So I'm just going to run through the review, and you can go at your own pace. If you need to fast forward because you understand the question, then fast forward. If you need more explanation, if you need to slow it down, rewatch it, you're free to do all of those things. So let's get rolling. So first one, remember when you have a parentheses around an expression being raised to an exponent, that exponent applies to everything inside of that parentheses. So the -2 is being squared. So -2 times a -2, I gotta get to the pens. A -2 times a -2 is 4. X squared is x squared. Then the 3 raised to the third power is 3 times 3 times 3, which is 27. When I have a power raised to another power, I multiply the exponents, and I get x to the 6th. Now, when we have two things multiplied together, I just multiply the numbers just like I would multiply anything. So 4 times 27 is just 108. X squared times x to the 6th, when you multiply like bases, you add the exponents. Question number 1, 108, x to the 8th. All right, question 2. When I divide, I need to look at each piece separately, meaning I want to look at the numbers, 12 and the 6, and then look at the variables. So the first thing I'm going to do is just simply divide 12 and 6, and I get 2. Had those not been divisible, I would look at factors that go into each. I would reduce a fraction just like I reduce any old fraction. Okay? Next thing. When I have division with exponents, I subtract my exponents. So y to the 5th minus a -4 is y to the 9th. I add the exponents. Okay? Since the y to the 9th is positive, and the question or the directions say use only positive exponents, I'm done. Okay, number 3, just like number 1, when you have a parentheses, that exponent applies to everything inside the parentheses. So we have two options. I can reduce this thing first and then raise it to the third power, or I can raise it to the third power and then reduce. I'm going to do the first one. Sorry, that smart notebook is kind of in the way. It stays there unless I'm hooked to a smart board, which I'm not. I'm hooked to my laptop, so sorry about that. I'll have to make sure it tries to be out of the way. All right, so the fraction, I'm going to leave the fraction alone. The 2 and the 4 reduce down to 1 over 2. I'm going to leave the 1 out of there for a second just to see what ends up on top. So the 2's are done. The b's, I have 2 b's on bottom, 3 b's on top. So 2 of the b's will cancel on top, and I'll be left with 1 b on top, and there'll be no b's left on bottom. So that whole thing is raised to the third power. So I simply raise the top to the third power, and I raise the bottom to the third power. Remember, when you raise a number to an exponent, if you can evaluate it, you need to. So 2 to the third power, I can evaluate 2 to the third power, so I need to, and I get 8. All right. Question 4, pretty straightforward. X, when I multiply like bases, I add the exponents, so I get x to the 8th. All right, question 5. That 0 does not apply to the 3. That x is the only thing being raised to the 0 power. So this becomes 3 times 1, which is just 3. Anything raised to 0 power is 1, so 4 to the 0 is 1. That parentheses tells me, unlike the first term, this whole entire thing is being raised to the 0 power. So again, that whole big mess is just 1. And 3 plus 1 plus 1 is 5. All right, just like question 4, but a little more difficult is question 6. Multiply the 3 and the 6, and I get 18. Multiply like bases. X to the 5th times x to the 8th. I add my exponents, and I get a -3. Y to the 3rd times y to the 4th is y to the 7th. I add my exponents. Getting some stray marks sitting out here. Let's get rid of them. Okay, next thing. The directions say write with only positive exponent. So this x to the negative third needs to be written as 1 over x to the third. And that is technically correct. You won't see that written very many times in a math textbook or something like that. I would take that, but let's just make that a little neater, a little cleaner. And let's put that x to the third on the bottom, and let's put those other terms on top. So either this expression here or this expression here, either one of those is fine. All right, question 7. Whoops, too far. Question 7. Deal with your numbers first. So let's deal with all like terms. So 2 to the negative fifth power. I don't have any other whole numbers being raised to an exponent, so I'm going to look at this whole entire thing and see if I have any like terms. I have a base of 2, I have a base of, I have a base of 2, I have a base of x, and I have a base of y. None of them are the same. So I'm just going to rewrite this thing using only positive exponents. I can't simplify any further, meaning I can't combine like terms. So I'm simply going to get rid of these negative exponents. Remember our shortcuts. If I have an exponent that I want to change its sign, I simply move it across the division sign. So this 2 to the fifth needs to slide to the bottom and become a positive. The x to the third is already positive, so I'm going to leave it up there. And the y to the negative ninth is on the bottom. I want to make that a positive, so I'm going to rewrite that on top. Remember how I said before, if you have a number being raised to the exponent, we need to do that. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the bottom is 32. The top is y to the ninth, x to the third. And there's my answer. All right, this guy up here, we can think about this two ways. I'm just going to do my basic division rules. So I'm going to subtract exponents, top exponent minus the bottom exponent, and I get x to the negative 16th, which is 1 over x to the 16th. Okay? All right, question 9. A couple ways we can do this. Remember, this means 1 over 3x squared. Sorry, my squared did not look much like a squared. Okay, so I could do that. But remember what we also, oh, sorry, I cannot do that. Let me write that correctly. This becomes 1 over 3x squared. There we go. Right, the negative exponent takes whatever is inside or being acted on by the exponent and makes it 1 over. So remember, when we divide by a fraction, you multiply by the reciprocal. And so I could also go right to here and say this is 3x squared. Remember, the negative exponent simply flips a fraction. So I have no problem you going from the first step right to that step there. Final answer, 9x to the fourth. I square the 3, and I multiply the exponents just like we did back in a previous question. Okay, that one's a little tricky. All right, question 10. Very similar to question 3, I believe it was, up above. I'm going to reduce first, just like I did before. The 2 and the 6 reduce down to 1 and 3. 3 is on the bottom. I have 5 m's on top. Oh, that's an n on the bottom. All right, that's all I can do then. I can just reduce my coefficients or my constants. And now I'm simply going to square all my terms. So m to the 5th squared is m to the 10th because I multiply exponents. 3 squared is 9, n squared squared. I multiply the exponents and I get 4. And there's my answer. Number 11, I'm going to multiply the top. X to the 4th times x to the 1st is x to the 5th. I have 5 x's on top. I have 7 on bottom. 5 of the x's on top will cancel with 5 of the x's on bottom, and I'll be left with 2 x's on the bottom. If you wanted to do this, subtract exponents, we get x to the negative second power, which is 1 over x squared. Either thought process, totally fun. Okay, that smart notebook. It's kind of in the way. All right, we've done this one 2 or 3 times. I'm going to square the 4. I'm going to square the x to the third and get x to the 6th. We multiply exponents. All right, one of the standards on the test is being able to simplify exponents, terms with exponents. All right, let's jump down. Next concept. We need to be able to recognize whether something is linear or exponential in terms of a graph, in terms of an equation, and in terms of a table. So here we're going to be starting with a table. We're going to identify the pattern. Based upon that pattern, ask yourself the question, is it linear, is it exponential based upon the pattern? Then we're going to write an equation based upon whether it's linear or exponential, and then we'll sketch a graph. And from that, we'll see the difference between a table, an equation, and a graph of linear and exponential functions. Okay, if this is not in your notes, a linear equation, basic form, y equals mx plus b. An exponential equation, basic form, y equals ab to the x. Okay, so we need that to help us write the equation, but I just want to get that up there on the screen to start with. Okay, first thing, what's my pattern? So the first thing I'm going to figure out is how do I get from a 2 to a 4 by adding something. So if I go from a 2 to a 4, I need to add 2. If I go from a 4 to an 8, that doesn't work. If I add 2, I end up only at 6. So that doesn't work. I know it's not linear. It does not go up by the same amount every time. Next step, how do I get from a 2 to a 4? By multiplying. So I multiply 2 times 2 and I get 4. 4 times 2 gives me 8. 8 times 2 does give me 16. 16 times 2 does give me 32. What is my pattern? Times by 2. Okay, linear. You add the same amount every time. Be careful, that could also be subtracting, right? We could add a negative. Exponential, you multiply by the same amount every time. Again, be careful, that could be dividing, meaning like multiplying by a half or a third and so on. Okay, so this one is multiplying by the same amount. It is exponential. So I know I'm looking at y equals ab to the x. What is a? A is my initial value. What does that mean? That means it's the value of y when x is 0. That is 2. Y equals 2, right? Times, what's my pattern? Well, we're multiplying by 2. Okay, so that's my b value raised to the x power. And there we go. There's my equation. Question 15, looking at the pattern. 81 to 27. Well, I know I'm subtracting something. I'm not even sure what that is, so it's 54. So 27 minus 54, clearly not 9. So I know it's not linear. How do I get from 81 to 27? I divide by 3. What if I don't know that? Well, then I just can take the 27 and divide it by 81. Or take the 9 and divide it by 27. Or take the 3 and divide it by the 9. Or I could go 81 divided by 27, 27 divided by 3, 9 divided by 3, and so on, to find my pattern. We're dividing by 3. Well, in exponentials, there's no really such thing as division. So dividing by 3 is the same as timesing by 1/3. Let me write that more how we want it on the test. I would say multiply by 1/3. So what's happening here? We're multiplying by 1/3. So I know it's exponential because we're multiplying. My equation then, y equals, my initial value is 81. My b value is 1/3. Be careful, you need parentheses. If you want, you can stick a times sign in there. You don't have to. 81 parentheses 1/3 of the x means 81 times 1/3 to the x. Okay, to sketch a graph, you're just going to plot points. Okay, when x is 0, y is 2. Oh, that's not even on my screen. When x is, wow. That's not a very good graph, is it? That's a bummer. My x-axis is sitting down here somewhere. All right. More than that. Anyways, we're just going to plot points. When it's 3, it's 16, and you should get a linear equation. 1, 2, 3 is 16. 4 is 32. 2 is 8. 2 is 8, like sitting right there. And my equation, my graph would come through here. 0 was 2, which is down there somewhere. Anyways, my graph looks like that. Sorry, that was not a good graph. 1 is 27. I got same problem. Shoot. We'll talk about this in class. When it's 1, it's 87. 0 is 81. 1 is 27. 2 is 9. So my 2 being 9 can sit like right here. Yeah, I'm not going to get hardly anything. Whoops, right here. My graph is going to come like this. Really steep. And it's going to flatten out. But we can't see that. All right. Sorry, that was horrible. Question 14. Get rid of this mess. Looking at my pattern. From 5 to 7, we add 2. From 7 to 9, we add 2. From 9 to 11, we add 2. What is the pattern? Add 2. So I know it's linear. We're adding the same amount. My equation is y equals mx plus b. M is my rate of change, or my pattern. We're adding 2. So it's going to be 2 times x. M is 2. Don't think it's adding 2, so I need to put like x plus 2 there or something. If it was subtracting 2, it'd be a negative 2. And since it's adding 2, we're going to put a positive 2 as m. Okay, did you hear how I said that? My m is a positive 2. You could put plus 2 right here, but you know we don't need that. So I'm just going to put 2. Had it been subtracting 2, I'd have put a negative 2 in front of that. All right, plus b. My b value is my y-intercept, or it's the value of y when x is 0. And I get plus 5. Okay, identify the pattern. Looks like it's going down by 3 from 12 to 9, down by 3, down by 3, down by 3. My pattern is minus 3. And again, there's no such thing as subtraction in arithmetic sequences. We're going to say we're going to add a negative 3. So that's linear. My equation, y equals a negative 3x plus b. And my b is the y-intercept, which is 12. And I'm not going to graph because I have a horrible xy axis. All right, next concept. We should be able to graph an exponential. We should be able to state the domain, the range, and the asymptotes. Okay? So, first thing I'm going to do is fill out my table. So when x is negative 2, I have 3 times 2 raised to the negative 2 power. If you want to grab a calculator and type that in, you can, but we can also do this fairly easily in our head. 2 to the negative 2nd power means 1 over 2 squared, which is 1 over 4. 3 times 1 over 4 is 3 over 4. If you want to type that into the calculator, you would have got a 0.75 right there. Okay, if you type that into the calculator, you would have got 0.75. All right, put in a negative 1. Plugging in negative 1 here, this becomes 1 over, this becomes 1 over 2. And 3 times 1 over 2 is 1.5, or 1 1/2, or 3 over 2. Any of those is fine. Anything raised to 0 power is 1, so this becomes a 3. If I take the negative sign away, this becomes 3 times 2, which is 6. If I put a 2 in there, this becomes 3 times 2 squared, which is 3 times 4, which is 12. Right, now some of you started with this right here. You put in 0, and then you just saw that the pattern was timesing by 2, and you went left and right of that, or up and down from that, and that works great. That's totally fine. I just started right from the top and worked my way down. Okay, this one I can graph. That's 0, 3, and then 1, 6, and then 2, 12, 1, negative 1, negative 1, 1.5, and so on. My graph will never hit the x-axis. I'm going to come right alongside that. I know it looks like I hit the x-axis. Pretend I didn't. And then it cruises up like that. Go ahead and do the domain and range while we're at it. Domain. All exponentials have a domain of all real numbers. The range. Look at my y values. Look at your graph. There are no negative y values. All my y values are greater than 0. So my range, y, is greater than 0. Remember, my domain, or my range and my asymptote goes together. My asymptote is y equals 0, and my range will either be above that or below that, depending upon the equation. All right, so there is question 17. Question 18. I'm going to fill out the table by starting in the middle. At x equals 0, y is 1. When x equals 1, I get 1/2, right? I get negative 1 times 1/2 raised to the first, so I get negative half. And then we're going to take half of that, and I get negative 4. Oh, sorry. Wow. Trying to do 2 things at once, not working. This becomes negative 1/4. I put in a 2 up here, and so on. Okay, negative 1. What does that look like? I put in a negative 1 up here. Negative flips my fraction, right? So I end up with a negative 2 over 1 to the first power, which is just a negative 2. If I put in a 2 up here, I get negative 2 squared, which is a negative 4. Right? Look at my pattern. My base is a 1/2, meaning as x gets bigger, y is going to cut in half. So when x goes from a negative 2 to negative 1, y cut in half, y cut in half, y cut in half, and so on. We have exponential decay flipped upside down. So when x is 0, y is a negative 1. When x is 1, y is a half. Then it's a quarter, and so on. Negative 2, negative 4, negative 8, negative 16. I know those are not in my table, but I know them. All right, domain. Domain is all, sorry, it jumped back on me. Domain is all real numbers. Not sure where that came from. Domain is all real numbers. Range, nope, let's do asymptote. Asymptote is y equals 0. Now, because y, my graph is going to approach that. Not sure why it keeps jumping. My graph is going to approach the x-axis, so my asymptote is y equals 0, but this time it's coming from the bottom. So I know my range is y is less than 0. In question 17, it was above the x-axis, so it's y is equal to, it was above the x-axis, so it's y is greater than 0. For question 18, it's below the y-axis, so it's y is less than 0. Okay, if you're getting the hang of it, pause question 19 and give it a try. Okay, I'm going to start in the middle. When x is 0, y is 6. Nope, y is 2, because this becomes 1 times 2 is 2. Okay, and so when x is 1, I'm going to multiply by 3 and I get 6. When x is 2, I'm going to multiply by 3 and get 18. My pattern is times by 3. Going backwards, I divide it by 3. So 2 divided by 3, I divide by 3 again, I get 2 divided by 9. If you type it into the calculator, this is what, 0.666, etc. This becomes like 0.222, etc. Either one of those is fine. You got your graph. When x is 0, y is 2. When x is 1, y is 6. When x is 2, y is 18. When x is negative 1, it's 2/3. And then 2.22, and so on. That wasn't great. Cruise along the x-axis and up. Domain, all real numbers. Range, y is greater than, it's above the x-axis, 0, and asymptote, y equals 0. Question 20. If x is 0, y is a negative 18. That is my y-intercept. When I go to 1, this 1/3 says I'm going to divide by 3, so I get negative 6. I divide by 3 again, I get negative 2. Going the other way, I multiply by 3 and I get negative 54. And I get negative 162. When x is 0, y is a negative 18. When x is 0, y is a negative 18. When x is 1, y is a negative 6. When x is 2, y is a negative 2. When x is 3, y is really, really small, and we get that. Domain, all real numbers. Range, y is below the x-axis, so y is less than 0. Asymptote, y equals 0. All right, question 21. Moving on now, word problems. So make sure you have your equations written down. I'll write each equation down for each question as we go. So you make sure you have those in your notes. 21. You purchased an antique desk from a famous woodworker for $2,500. The value of the desk is increasing. Not sure why I did that. Increasing at 7% a year. Okay, right. Having a hard time controlling the computer. Write a function that represents the value of the desk after t years. Make sure you hear this. For this answer, your answer must have a t in it and not a number in place of t. That happens in question B. Question 21a, you must have y equals something with a t left in it. First question. Let's get rid of the ones that we know for sure it's not. Is it half-life? Nope. Nowhere in there does it talk about half-life. Is it compound interest? Nope. Nowhere in there does it talk about compound interest. This is a basic exponential growth, because it's increasing, equation. My basic exponential growth equation is that guy there. Y equals a times 1 plus r raised to the t power. That stays. And that stays. I am plugging in for A, and I'm plugging in for R. Reading through here, remember my A is my initial value. So what is my initial value? $2,500. That is what we purchased the antique desk for. But that desk is increasing at 7%. Changing that percent into a decimal, meaning dropping the percent sign, I must either divide by 100 to get my decimal, or simply move my decimal 2 places to the left. Either way, I get 0.07. Question B, plug in that into my calculator with a 12 in there. And when you do that, sorry, I have not done that yet, so we'll do that really quick. 2,500 parentheses 1 plus 0.07 raised to the 12th power. And I get $5,630. It is money, so we're going to round to 2 decimal places and 48 cents. Throw a dollar sign out in front, and we got our answer. Question 22, you buy a new fishing boat for $25,000. However, this time, the value is decreasing by 4%. Again, there's no mention of half-life. There's no mention of compound interest. It's a basic exponential decay. So now it's 1 minus r raised to the t power. So just like before, the y stays as y. The a is my initial value. The 1 plus r now becomes 1 minus r. And my r is 4%, 0.04, raised to the t power. What's the value of the boat after 10 years? I simply type that equation into my calculator. And t is 10. So I get y equals 25,000. I would definitely rewrite this on your test. Don't just try to do it in your head. rewrite it so you know what you're doing and know what you're typing in. And I get $16,620.82. Okay? Make sure you include units. Dollars would be question 21 and 22. Make sure you round to 2 decimal places because dollars round to 2 decimal places. Okay, here's exponential growth, exponential decay. Let's keep on and going. You invest $20,000 in the stock market. Your financial advisor tells you it will earn 4% annual interest rate compounded, keyword, quarterly. Now I know I am using compound equations, so y equals principal. You can call it A or P, it doesn't really matter. Times 1 plus R over N raised to the NT. P, my principal, my initial amount, 20,000. 1 plus R. R is 4%, 0.04. But we are earning interest compounded quarterly. Quarterly means 4 times a year. So both this N and this N are 4. 20,000 for the initial value. N is 4. 0.04 is R. And remember, T stays as T. So now we're going to do the exact same thing. But now we're going to plug in 7 for T. I like to do this upper exponent in my head. 4 times 7 is 28. If you can't do multiplication in your head, then make sure you put parentheses around that puppy when you plug it into the calculator. 4 times 7. So grab your calculator. Make sure you can type it in correctly. Don't just assume you can. And type this thing in. And make sure you get, I'm going to double check my work before I hit enter. I got $26,425.82. Make sure you either put parentheses in the exponent or you do that multiplication first and then plug it in as just a number like 28. Okay, 24. Initially, there is 42 milligrams of radioactive isotope that has a half-life of 52.4 days. So when you think about it, these equations really aren't that hard, or these questions aren't that hard. It tells you what to do. If you want to use compound interest, it'll say compound interest. If you need to use half-life formula, it'll say half-life. Okay, so just make sure you're picking up on the keys that the question's putting down. Okay, so we have A times 1/2. Those little stray marks, 1/2 raised to the T over H power. If you don't have that in your notes, make sure you get that in there. A, just like always, is the initial value. There's 42 milligrams, that's my A, half is a half, of a radioactive isotope that has a half-life of 52.4 days. So the T is up on top, the 52.4 days is underneath. Now, on the test, don't write this. 42 times 1/2 raised to the T over 52.4 days. That is not written as an exponent. Okay? That is not correct. Do I know what you mean? I don't know if I know what you mean because that's not written as an exponent. So do you know it's supposed to be an exponent? Don't say, well, yeah, obviously. That is not obviously. Okay? So make sure you clearly write it as an exponent. It has to be up in the exponent position. Okay? All right. How many milligrams will be left after 12 years? Plug in 12. A lot of people ask, can I change that 0.5 or that 1/2 to 0.5? Absolutely. Be careful. I almost made a mistake. Notice my units. The radioactive isotope has a half-life of 52.4 days. How much will be left after 12 years? How many days is 12 years? There's 365 days in a year. We're going to skip the leap year thing. So 12 times 365 equals 4,380 days. When you erase this, because it's kind of in the way, I'm going to jump down here. Y equals 42 times 1/2 to the 4,380 divided by 52.4. Type that into your calculator. Make sure we get the same answer. 42 parentheses 1/2 raised to the parentheses by 4,380 divided by 52.4. What do you think this answer should be? Big or small? How many times will this thing be cut in half in 380 days? A lot. This should be a very small number. When you hit enter, I get 2.88, this e to the negative 24 thing. What does this mean? Think back to your scientific notation, back to science class. That means move the decimal place 24 places to the left. Some of you may say, well, that's just 0. Yeah, it pretty much is 0. There's pretty much nothing left. But there is something. There is 2.89 times 10 to the negative 24th milligrams left. Okay? All right. Question 25. How do you determine whether a function is exponential growth or decay? If r is less than 1, we're assuming r is greater than 0. Okay, so if r is between 0, well, I am anyways, but I think our textbook actually allows r to be negative, which is not normal. So r can be less than 1, but greater than 0. If r is negative, it does a weird thing. It bounces back and forth across the x-axis, and technically it's really not an exponential equation. Okay? It's not a continuous function, so it can't be anyways. If r is greater than 1, it is growth. This is decay. This is growth. All right. Now, question number 26. We need to, based upon what we just said, look at this equation and ask, is this growth or decay? Remember, this is y equals a times 1, either plus r or minus r, depending upon growth or decay. So this piece right here is either 1 minus r or it's 1 plus r. It's less than 1. So I know it's decay. I know we've subtracted. Okay, we had a 1 minus r. And we ended up with 0.89. So we have decay, it's less than 1. What was the r that we subtracted? The easiest way to find it is just take 1 minus whatever's written there. And I get 0.11. So my r is 0.11. Or 11%. And you can write it either way. I'll take 0.11 or I'll take 11%. Question 27. It is growth. This is now greater than 1. It's growth. This one's easy. If I have 1 plus something and I end up with 1.73, what did we add? 0.73 or 73%. Okay, 28. If you need to hit pause, if you can hit pause, if you know what you're doing, hit pause and give 28 a try. For some reason, mine keeps jumping back and forth. Okay, greater than 1, it is growth. How much greater than 1? 0.02, which is 2%. Question 29. It is decay. It's less than 1. How much less? I'm going to take 1, subtract 0.98, and I get, again, 0.02. R is 0.02, or 2%. This time, though, we're subtracting 0.02, whereas last time we were adding. Same R value, but 1 is growth and 1 is decay. And that is totally fine. Okay. Use that sequence for problems 30 and 31. Write the nth term. Just like before when we wrote the equation, and I said t has to be in the equation, this one's the same. We're writing the equation, so n has to be left in the equation. So if it's arithmetic, it looks like that. If it's geometric, it looks like that. The n must be left in the equation, and the a sub n must be left in the equation. Write the nth term equation. That is what a sub n stands for. If those two equations are not in your notes with some explanation, this is arithmetic, this is geometric, etc. If those are not in your notes, make sure they go into your notes. Okay, I'm gonna get rid of them because we got to write our equation there. First question, are we adding the same amount, which means arithmetic, or are we multiplying by the same amount? Same as we asked when we asked if it's linear or exponential, same question. So question 30, sequence goes from 22 to 18, we subtracted 4. From 18 to 14, we subtracted 4. We subtract 4 to get to 10, we subtract, my pattern is we're going to subtract 4. So it is arithmetic. So here's my equation. A sub n, a sub 1 plus n minus 1 times d. What is my a sub 1? My first term. Remember the n minus 1 stays. What is my d? We are subtracting 4. We've talked about this a lot. Do not forget the parentheses. If you don't have the parentheses, it's this looks like I'm going to take that equation and I'm going to subtract 4. It's not what I'm doing. I'm multiplying that by a negative 4. So make sure you have the parentheses in there. It is a different equation without them. Don't say, oh, well, it's close. Well, close is not the same equation. It would not be marked correct. Okay, make sure you have the parentheses in there. Okay, everything's the same, except for now I'm looking for the 20th term. So n is 20. Plug in 20 for n, grab a calculator, type it in, and work it out. So I get 22 plus 20 minus 1 times a negative 4. And I come up with a negative 54. So a sub 20 equals a negative 54. Now, you don't have the equation, can you just subtract 4 until you get the 20th term? Absolutely. Okay, you will get a couple points, but you won't get a 4. Okay, question 32. What's happening? From a negative 2 to negative 6, looks like we're going down by 4, but that is not the case from a negative 6 to negative 18. So next check. What are we multiplying by? Well, it looks like multiplying by 3. Times by 3 to get to 6, times by 3 to get to 18, times by 3 to get to 54, etc. So I know it is geometric, which is this equation. A sub n, nth term, equals a sub 1, my first term, r. What are we doing? We're multiplying by 3. So my r is 3. If we were dividing by 3, my r would be 1/3. Okay, plug in 10 now. So a sub 10 equals negative 2 times 3 to the 10 minus 1. Just like before, since you have more than one term in the exponent, you must put parentheses in that, or just do that in your head. You know what 10 minus 1 is. Just do that in your head. So negative 2 times 3 raised to the 9th power. And I get a large number. Don't be spooked about large numbers. Exponential growth and exponential decay generate large numbers very fast. Negative 39,366. Okay, last two. Hit pause if you can and try the problem. Looks like to me we're dividing by 2 every time. If you're not sure, just take the first term and divide it by the second term, and you should get 2. Or you can take the 128 divided by 264, and you should get 0.5 every time. So my pattern is a sub n times or equals a sub 1 times r, and r is 1/2 raised to the n minus 1. Use my equation to find the 11th term, and I have 1/2 raised to the 11 minus 1. Again, I know that in my head, I can do that. So 264 times 1/2, which you could call 0.5, raised to the 10th, and I get 0.2578, etc. I'm going to 3 decimal places, 0.258. Okay, last question. 5, 8, 11, 14 looks pretty arithmetic to me. We're adding 3 every time. So my equation, a sub n equals a1 plus n minus 1 times d. When it's a positive d, you don't have to have the parentheses because a 3 touching the parentheses means multiply. There's no negative sign to make it look like subtraction. So we're good to go. Excuse me. So a sub 10, the 10th term is 5 plus 10 minus 1 times 3. Again, I know what 10 minus 1 is. It's 9. 9 times 3 is 27. Plus 5 is 32. If you want to grab your calculator and check it, you may, but there is that one. Whew, we made it. All right. Hope that helped. Good luck on the test tomorrow.